All right, so today in class, I want you to follow along with the video, take your notes in your notebook. You'll be able to do some of assignment 1 for chapter 7. You're going to turn in the notes that you took during class from the video, and then you can start working on assignment 1. We will finish the rest of the notes tomorrow in class when I'm back. You're done with the trigonometry units, so we're going to be getting back into some Algebra 2 to, again, help us prepare for calculus, because this class is called Pre-Calculus. All right, so what we're looking at is polynomials and special functions. What is a polynomial function? It's in the form of f of x equals ax squared plus bx plus c. We could make it a cubic function, which is degree 3. We could make it a quartic function, which is degree 4, and so on. So I have an example here, which is in red, which is 4x cubed plus 2x squared plus x minus 3, and that's a polynomial function. You just need to make sure your exponents are integers and they're positive. And that's, you can see the 3, 2, 1 when looking at your exponents, which are these right here. And you always want to write it in descending order. When you write it in descending order, the number in front right here is called your leading coefficient. And that's really telling us what's happening as our x values gets really big and goes to infinity, or the x values get really small and go to negative infinity. Technically, you have a bunch of coefficients, okay? 4 is a coefficient, 2 is a coefficient, 1, negative 3. They are all coefficients. But the leading coefficient is the important piece here, and that in this case is the 4. And that's because it's in front of the x value that has the greatest exponent, the highest exponent. All right, so if you need to pause it just to fill this in into your notes, then pause the video. Next, what we're going to look at is to describe the end behavior. We're going to be using that leading coefficient. And you might be wondering, what is the end behavior? Well, think about what a polynomial function looks like. This right here is an example of a polynomial function. It's smooth, it's continuous, there's no sharp turns. The end behavior is what's happening. I'm highlighting it here in red or pink. What's happening as x gets really big or small. So to the right of the function, it's either going to go up to infinity or down to negative infinity. We use the leading coefficient, okay? So that right there tells us the right side of the graph. So if it's positive, it's going up. If it's negative, it's going down. Then the degree tells us what's happening on the left side. And how does the degree help us? So think about if you have a degree 2 versus a degree 3. So this graph that I have over here sketched out is probably a degree 3. We definitely know it's odd, but the least degree it could be is degree 3. Can't be degree 1 because that's a line, right? So you can see that with a degree 3, or even if it was a degree 5, the ends are opposite direction. One side's going to be going up, one side's going to be going down. Now think about a degree 2 function. What type of degree 2 function have you worked with since Algebra 1? That's a quadratic. And a quadratic looks like a U, either opening up or opening down. Notice that the ends go the same direction. So that's where the degree helps us, okay? So if it's an odd degree, you know you have to have one end going up to infinity, one end going down to negative infinity. If it's even, they go the same direction. So what we're going to look at is a few examples just of end behavior based on a positive leading coefficient and a negative leading coefficient, and whether we have an even or odd degree polynomial. So again, if you need to pause it to catch up, go ahead and pause it. Otherwise, we're going to continue on. Okay, so we're first going to look at if we have a positive leading coefficient. So with an even degree polynomial, an example could be y equals 4x squared plus 1. The degree of that polynomial is 2. It's a quadratic. And your leading coefficient is a positive 4. Okay, so what that's telling you here, if we looked at our graph, we know it's a parabola. We know that this parabola is opening up, okay? And that's because 4 is a positive number. And so our right side is going to go up. Because it's degree 2, both ends must be going the same direction. And we know that anyways because we know characteristics about a quadratic. So if you think about your end behavior, as x gets really big, that means when you look to the right of the graph over here, your y value is going up to infinity. As x gets really small and goes to the left side, notice it also goes up. So these are always going to match. Y going to infinity because it's an even function, okay? Now, if we look at an odd degree polynomial, so an example over here could be y equals 3x to the third, okay? To the right, it's going to be going up because your leading coefficient in front, which is this, is positive. So that's how we know that that right side is going up. Now, because it's degree 3, 3x cubed, the other side is going to be going down. It's going to be opposite. So when we look at our end behavior here, the right side is going up to infinity because our leading coefficient is a positive number. Because the function itself is odd, when we go to the left, it's going to go the opposite direction, okay? So an odd degree polynomial, the ends go opposite direction. Even degree polynomials, they go the same. So I want you to think about this. If we were to redo this little section with a negative leading coefficient, how would this all change? So go ahead and pause it and write out what you know if we have a negative leading coefficient. How is that going to change our end behavior? Okay, so I sketched out a couple pictures here. Hopefully you took some time to do the same. Negative leading coefficient. Again, what is that telling us? That's telling us this right side, okay? So if we see a negative leading coefficient, we know the right side is going to go down to negative infinity. Now, because it's an even degree, both ends are going down. So even degree tells us the ends are the same. Negative leading coefficient tells us which direction. Now, if you look over at this other one, you have a negative leading coefficient, so that's why the right side is going down to negative infinity. But because it's an odd degree, they're going to be going opposite directions. So one goes to negative, one goes to positive infinity. If you need to pause it to fill this in, go ahead and do that. Okay, so I have a couple written out here, and we're going to, without graphing them, determine the end behavior. So in order to do that, you always look at your leading term and your degree. So if it isn't in descending order of your exponents, you rewrite it. The first one already is written like that. The rest of it, honestly, doesn't matter. So what we see here is your leading coefficient is positive. So that means to the right, when you look at the graph, it's going to be going up. So as x goes to infinity, y is going to go to infinity. Okay? Now, to figure out what's happening on the left-hand side as x gets smaller, you look at the degree. Since it's odd, they must go opposite directions. So instead of positive, it's going to go negative. So if you took some time and threw 2x cubed minus 3x plus 1 into Desmos or a graphing calculator, I don't know what's happening in between there, but that is what's happening at the ends. Okay? Now, part B, notice it's not in descending order of your exponents. This is technically the term we're looking at. Okay? So negative 4 is actually our leading coefficient. And this is the one we're looking at because it's the one with the greatest degree, okay, or the greatest exponent. So since the leading coefficient is negative, to the right, it's going to be going down. And then, because it's degree 5, which is an odd number, as you go to the left, your on behavior is going to go the opposite direction. So this side's going to go up to positive infinity. Okay? Now, like I said, you'll be able to start and do some of the homework. You won't be able to finish it, so it'll be due on Friday instead of Thursday. We will wrap up on behavior and looking at the zeros and multiplicity on Thursday. So then you'll be able to finish up day one after Thursday's lesson. So what I want you to do is submit your notes that you took today in class to Canvas. You will get points for those, so please do that. And then go ahead and give some of day one a try. And a lot of this, or most of this, is all from Algebra 2, so you might even be able to do more depending on what you remember from last year.